All right, this is section 1.7, solving absolute values and inequalities. A compound inequality is kind of like a compound sentence. If you remember back from English, Tom went to the store and Cindy went to the park. They both have a subject and they both have a verb. So two types of compound sentence when it comes to inequalities are the first type is called an and sentence or an intersection. And basically the solution is the numbers that are found in both inequalities. Like if your mom told you you have to take out the trash and you have to clean your room. You have to do both for it to be considered obedience. So on these, the numbers have to work in both. This right here is a compound intersection. This center part right here goes with both this part and with this part, and it's considered an and sentence. So I'm looking for the part that they have in common. So I'm going to make two equations here. I have 9 is less than 3x plus 6. And then that center part also goes with the 15. So I have 3x plus 6 is less than 15. Now I have two equations to solve for, and I'm going to find the part that they have in common. I'm going to go ahead and switch sides here. So I have my variable on the left side. Notice if the wide part is next to the 3x plus 6, it also has to be next to it when you switch sides. So I'm going to subtract 6 from both sides. So I have 3x is greater than 3. And then I'm going to divide by the 3, so I have x is greater than 1. Over here, I'm going to subtract my 6, so I have 3x is less than 9. And then I'm going to divide, so I have a 3. So I'm going to graph these on a number line. I'm going to put the 1, and I'm going to put the 3. Notice that I have greater than the 1, so it goes in that direction. I have less than the 3, so it goes in that direction. And the part that they have in common is that part. So if I were to write this, I would write this x is greater than 1 and less than 3. Those numbers that are between there are what those two equations, this which translates into this and this, have in common. So the solution set are the numbers between 1 and 3. If they didn't have anything in common, because it's an and sentence, I would put an empty set, but I am looking for the numbers that are in both this equation or this inequality and this inequality. The other type of compound sentence you have is called a union, and that has to do with or. If your mom said you can clean your room or take out the trash, then doing either one of those things would be considered obedience. So I have my two sentences here, separated by the or statement. So I'm going to add the 3. So I have x is greater than 4. And I'm going to subtract the 1. So I have x is less than or equal to negative 1. So when I put these on a number line, notice it does have a line underneath it. The negative 1 is on the left-hand side. The positive 4 is on the right-hand side. So greater than 4, I'm going to fill in the circle. And it goes in that direction. I'm going to fill in the circle, because I have a line underneath it, and it goes in that direction. Now notice that these don't have anything in common, okay? There's no numbers that are in both of those. But because this is an or, which it says right there, it doesn't matter that they don't have anything in common. I'm looking for the numbers that are included in either one. I could write this as x is greater than or equal to 4, or x is less than or equal to negative 1. All right, now you try a couple of these. You solve them and you graph them. I've got a shadow here, but hopefully you can still see it. So pause the graph and then come back to it and make sure you got them correct. So this is an and statement, because see that center section goes with both sides, so I know that's an and. So I have 8 is less than m plus 6, and m plus 6 is less than 14. I'm going to switch these sides, so I have m plus 6 is greater than 8. I'm going to add the 6, so I have m is greater than 14. This one I'm going to subtract the 6, so I have m is less than 8. So if I look here, I put the 8 on the left-hand side, the 14 on the right-hand side. This goes in this direction. This goes in this direction. I'm looking for what they have in common because they're an and statement. They have nothing in common, so this is an empty set. They have nothing in common. This one's an or statement, so I have a negative 3 is less than or equal to 2y plus 9, or 18 is greater than or equal to 4y minus 10. I'm going to solve these, so actually I'm going to switch and put my inequality or my variable on the left-hand side. And that way it will be consistent with my number line, and I can just shade in the correct direction because my variable will be on the left. I'm going to subtract the 9, so I'm going to have a negative 12, and I'm going to divide by the 2, so I'm going to have a negative 6. This one I'm going to add the 10, so I'm going to have a 28, divide by the 4, so I'm going to have a 7 right there. So when I graph this, I have a negative 6, closed circle, because I have a line underneath it. Okay, it goes in this direction. And then I have a positive 7, closed circle, goes in this direction. Now notice, I'm looking for what they both, either one of them have. They don't have to have it in common. This is all the numbers this way. This is all the numbers this way. So when you have an or statement and they cross like that, you have all real numbers as your answer, because there's not a single thing on that number line that isn't included in one of those two equations. Then you're going to combine your compound inequalities and your absolute values. There's a trick here to know whether it's an and or an or statement. If you have the great or sign, I want you to exaggerate that, use your southern drawl, and think of it as a great or sign. So if you have this one, it's an or statement. Exaggerate on this one too. This is a less than sign, so you can think of that as an and statement. So put your southern drawl in there and that will work. Okay, on this you have a less than sign, so this is an and statement. You're looking for what they have in common. If you have an absolute value, you have two equations. You have it exactly as it is, and you write what's in the absolute value as it is, switch the direction of the inequality, and take the opposite sign of that. So then this is a, I don't have anything to solve, but I need to put it on my number line. So I have a 7, I have a negative 7. They're open circles. This one goes this direction, this one goes this direction. So what I'm solving for, what they have in common, is what's between them. A lot of times people will take a highlighter and highlight there. So y is going to be greater than negative 7 and less than positive 7. This one over here, this is a great or sign, so this is an or statement. So I have a 2x plus 4, just like it is in the absolute value, is greater than 12. And then I have a 2x plus 4 is less than or equal to negative 12. I'm going to take the opposite sign. Go ahead and solve this out. I have a 2x is greater than or equal to 8 because I'm subtracting the 4, and then I'm going to divide, so I get x is greater than 4. I'm going to subtract here, which is going to give me a negative 16, and then I'm going to divide, which is going to give me a negative 8. So I have negative 8, closed circle, shaded that way, positive 4, closed circle, shaded that way. Looks like they don't have anything in common, but remember this is an or statement, so I don't really care that they don't have anything in common. I can say x is greater than or equal to 4, or x is less than or equal to negative 8. Now you try some, pause the video, and then come back and make sure you got the right answer. This is a less than, so this is an and statement. So I have 8x is less than or equal to 24, and 8x is greater than or equal to negative 24. So when I solve this, I get a 3, and I get a negative 3. Positive 3, negative 3, closed circle goes this way, closed circle goes that way. So what they have in common is between them. So x is greater than or equal to negative 3, less than or equal to positive 3. This is a great OR, so it's an OR statement. So I have x plus 2 is greater than 5, and I have x plus 2 is less than 5. I'm going to subtract, so I have x is greater than 3. I'm going to subtract, oh, I forgot to put the negative on that one. X is less than negative 7. So when I graph here, I have a negative 7, open circle, goes that way. 3, open circle, goes that way. They don't have anything in common, but it doesn't matter because they're an OR statement. So x is going to be greater than 3, or x is going to be less than negative 7. And your homework is page 53, 16 through 44 all.